China's observation in a global context. So people say Earth observation is a powerful tool. Observation is useful technology. Earth observation is kind of science. So without observation, how about our life? So through the observation, we can monitor the environment. We can survey the resources. Even we can, discover some natural phenomena. And we can build our sustainable Earth. So observation is really a continuous viewing of our planet. Half a century ago, in 1962, in the world, we have the two important events. The first one, we are here, our IGARSS, that means actually the Geoscience and Remote Sensing Society was born. And in the meantime, the first, symposium of remote sensing environment was held in Andover. So that means through that the conference, that means remote sensing was born officially half a century ago. So today, I'm really glad to look back and look forward about the remote sensing activity. Firstly, about the global remote sensing history. Very important, several satellites. The Landsat opened the door of the global remote sensing technology and applications. It's 1960s. And in the 1980s, SPOT, still used a lot right now. SPOT 6 just launched recently, another important one. And in the 1990s, RADSAT-1 is the first commercial operational radar, wonderful image. And later, also in the end of 1990s, IGARSS, very, very high resolution data. And Terra, so with the Terra, how can we study the Earth science? And TerraSAR X and Tandem X, wonderful radar. So a lot of sensors, operate for optical and microwave, like other kind of UV set and other kind of satellite. So from here you can see from 1962 to 2020 in the world, lots of countries launched a lot of the satellite, like the very dark blue, that means one country already launched over 50 satellites. So that means the Australian satellite is being launched globally. Also in the past half century, we can see, if we say we divide into 4 stages. The first stage, only 14 satellites. The second stage, increasing, 43 satellites. And later, by end of the last century, it's 89 satellites. And just in the new century, the beginning of 12 years, the 174 satellites. Not only increasing of the number of the satellites, but also in the beginning, you can find that originally just developed country launched a lot of satellites, but recent years, developing countries also launched some satellites. So we have the satellite with the platform. What about the parameters? We make some comparison. Also, we can divide in 4 stages. In the first stage, you can see the spectral resolution 8 meters. Later, 10 to 30 meters. Later, 6 to 10 meters. But now, higher than 1 meter. And you can see the spectral coverage. Originally, just the visible infrared. Later, visible infrared, shortwave infrared, and thermal. And recent years, not only for that one, but also microwave. Not only passive microwave, but the active microwave. And here also you can see the spectral resolution. Originally it's multispectral, later it's hyperspectral. And also we can see the data storage. So the megabyte to gigabyte, to terabyte to gigabyte. So that means people say we are in the edge of the big data. So here we can see we're in the edge of the big Earth observation data. Right now we have a very big, very good Earth observation organization, a government organization. GEOS, everybody familiar with this. Right now already have the 89+1 government members, also the 67 international organization members. GEOS really play very, very important role in the Earth observation development. So look around the world. We think that the remote sensing and the observation have this kind of the characteristics. So we have the international observation systems. We have more and more international cooperation. We pay attention to the data sharing. Also in the meantime, countries, different organizations develop a lot of advanced technology. And the purpose, finally, is for applications. How about the social benefit? It's a key point. We are thinking, in the observation community in the world. So, what's the purpose for developing the high technology, increasing observation? The only one purpose, the key point one, is for application. So now, what's the key application field? People say environment. So how about the Earth, the future? The future Earth is the key part. So right now, a lot of people, a lot of organizations in the country focus on the future study. So I think really observation can play a very, very important role in the future for our future Earth by using remote sensing. Now moving about China. So how about China's observation development? China paid attention to the observation since the 1970s. Since then, there's a series of satellites. You can see different kind of satellite, like a meteorological satellite, like ocean satellite, resources satellite, environmental, even disaster monitoring satellite, and also some microsatellite and scientific experiment satellite. Also, not only for remote sensing, but also navigation. That's why we said yield satellite, but also spacecraft, also put some sensor there to do some observation activities. Firstly, you can see resources satellite. Actually, we have another name, we call it IGARSS. Why? Because it's a joint project between China and Brazil. China and Brazil also control satellite, so we call it the IGARSS. So the IGARSS is the name application is really the environment, resource, urban growth, etc., etc. And just last year, we launched the Resource 3 satellite. Actually, it's a surveillance mapping satellite. It's the first high-resolution 3D mapping satellite in the country. You can see it's 2.1 meter resolution. And actually, we have three kind of different sensors. Another one is 3.5 meter, and another one is 5.8 meter. So not only get a higher resolution image, but also within 1 year, get a lot of the products. So this is high resolution data. China, a lot of disasters and very polluting territories. So we launched some small satellite constellation, divided into two stages. For this constellation, for the first stage, launched the 3 satellites, including 2 orbiter and 1 SAR. And the second age launched, 8 satellites, 4 satellite orbiter, and another for its SAR satellites. Meteorological satellites. In this field, I think we do a lot of cooperation with different countries, including Australia. So, geological forecast, the first one, the polar orbiting meteorological satellite, and the second one, the geostationary meteorological satellite. So here is the roadmap since the 2006 to 2020. So we're launching a series of satellites using the different kind of sensors, not only optical but also a microwave. This ocean satellite little late compared with other kind of satellite. The first ocean satellite has launched in the year 2002. Until now, already launched 3 satellites we call the HY1A, HY1B, and LH2 satellite. Just the same with the meteorological satellite, the sensor from the visible infrared to the microwave. Also in the future, a couple years later, we have other 2 new satellites special study for ocean. In the meantime, China launched some micro satellite. You can see some micro satellite in Tsinghua 1 means Tsinghua University satellite. And Beijing 1 means Beijing City's satellite. In Beijing, they host the Olympic Games. They launched the satellite. They protect and monitor the environment. Recently, they have a plan to launch the Beijing 2 satellite. Meantime, also pay attention to build some scientific permanent satellite. We are facing the global challenge. So how to study the global change? We, the high-tech program, have a plan to launch the carbon satellite. So maybe next year, if on the plan, China is the first satellite for global CO2 monitoring satellite will be launched. And also we launched the electromagnetic and earthquake satellite because in the past 5 years, at least 3 great earthquakes occurred in China: Wentuan, Yushu, and the Lushan earthquake. I'm sorry to say, I just received a short message just a couple hours ago. Western China, we have another earthquake. So people say, what's your contribution to your remote sensing? People negotiating this for law. Somebody said remote sensing useful. Somebody said no useful. But we believe that, I do believe that remote sensing can play some role. But we should begin to do some study, including using the observation, the satellite to do something. Several years ago, China government approved the new, very huge, the observation program, the key program. One of them is the title is related to observation, a high resolution yield system. According to that, we launched a series of satellites, launched some scientific aircraft, and even airborne, the remote sensing satellite and the platform and the sensors. Also set up some data center and application facilities. Meantime, when we launched the remote sensing satellite, pay attention to navigation satellite study. So China has a Beidou satellite navigation system provide continuous navigation information and time. Already 16 satellites have been launched with positioning accuracy 10 meters. The 2020, the system will form a network with 5 geostationary orbit and 30 non-geostationary orbit satellites to achieve the global coverage. So this is a very simple the roadmap about China's Earth observing satellite. You can see the different kind of satellite. This roadmap was just until the 2020. Not only we build our own satellite, but do some international cooperation, do some data sharing. We should do some global collaboration with different countries and organizations. So we have the receiving stations. Receiving stations not only receive the China's the satellite, but also we receive the international, the Earth observing satellites. So you can see we select some kind of national advanced satellite receiving all of this data. So in the meantime, we launched some data sharing program, especially for mid-resolution remote sensing data. Not only what I mentioned that do some satellite, but also recently, since 1999, China already, launched the space aircraft from #1 to #10 recently. So in this kind of the spacecraft, we put some sensors like the optical sensors, like some marginal sensors, micro sensors, the radiometer, the microwave radiometer, and accelerometer, and altimeter there to study the ocean, the land, and the Earth. This is just some idea. We have the balloon, we have the remote sensing airplane, we have space shuttle, we have long Earth orbit satellite, we have geosynchronous satellite. But we have some idea. The higher you are, the better view you have. So in the future, can we just in the moon surface put some sensors? So establish some lunar-based remote sensing system. So especially for some special natural phenomena like the global environmental change phenomena, we think using the moon, this kind of special platform, special satellite may be more useful to look at our Earth. So what I said, develop some high technology, the purpose in for applications. China, how we do some applications for some social impacts. The first one, a very important one, pay attention to a lot for agriculture applications. Originally, we do some agriculture study within China, just a part of China. Later, the whole China. Now, a lot of countries in the world, we do some global study under the framework of the GEOS. So here you can see we establish some, we call the crop watch the system. Using this system, we can estimate the global crop production. Like in last year, we found some phenomena, because in Northern Hemisphere, because we have drought affecting the wheat production in Russia and Ukraine. So from this map, you can see some results. And China, we have a lot of the natural disaster, not only earthquake, but some storms, some flood, drought, said even fire. So that's why we launched the special satellite, the natural disaster satellite, monitoring satellite. Meantime, we have the airborne platform. So we established some remote sensing emergency response system. So when we have some disaster like an earthquake, we can immediately receive data, send our aircraft to monitor the area. So later, just send out information for decision. Just last year, in my organization, RADI, we established some new organization we call the CASPAR Center of Excellence on Space Technology for Disaster Mitigation, CAS in China in Sciences. CAS means Developing Country Academy. Here you can see we use space technology for study the disaster, special for developing countries. And also people say, global change study is the first priority in application fields. So we really pay attention to that. But global change not only for one small area, not only one country. So we should study sometimes the global change. So here you can see, based on the remote sensing data, we have the products and the global land surface work distribution. And this one is for global changes of vegetation. The leaf area index dynamic. The dynamic you can see in 30 years in the world and 30 years in Asia. And you can see the different year. We have the different kind of the result. Apart that, using remote sensing, we can study the global change. We initiate some with our colleagues around the world, the ABCC program. The title is really the comprehensive study of remote sensing for global environment change. Why ABCC? A, Australia; B, Brazil; C, Canada; and now C, China. So ABCC program uses remote sensing for study the global change because the four countries is so important. Located south hemisphere, north hemisphere, east hemisphere, western hemisphere. Each country over 7 millions square kilometers. Recently, some countries also involved this, like Germany, like Malaysia. We welcome different countries involved in this joint this international cooperation program for study the global change by using remote sensing. Also, we have different applications by using meteorological satellites. You can see the global product unit for global total column horizon distribution monitored by moving satellites and other kind of products. And this is the ocean satellites, the products you can see by using the macro accelerometer, the macro radiometer, get the high resolutions, the ocean surface temperature, and some wavelengths, phenomena. And also, one of the important application field is natural and cultural heritage. So around the world now, over 900 world heritage. So we use remote sensing can, help the decision maker do a lot. Several years ago, the UNESCO established a cultural center in my organization. We call it the HEATS. The HEATS is just that technology for, the natural and cultural heritage study. So also, in the past several years, get some kind of preliminary result. Digital Earth. So in our RADI, we are building out the Digital Earth science platform. So this platform is actually is an infrastructure, but also is a whole application platform based on observation, using the Digital Earth, the platform, we can provide a lot of different fields of the application result. Well, this year and last year, we celebrated the observation's the 50th anniversary. So right now, maybe we should say bye for the last 50th century. But we are facing the big challenge for the global change. So using remote sensing, we can do a lot. We hope we can work together, develop our new generations observation for our, the future build of a really international cooperation, observation, new platform, create our brighter future. Thank you for your attention.